All right, lesson 7, a combination of everything that we actually know. I'd encourage you to do investigation 1 through 4, practicing translations, stretches, horizontal and vertical. I'm going to give you the conclusion answers that you should come to. For investigation 1, if you combine a horizontal stretch and a vertical stretch, it actually doesn't matter in which way the order is performed, so there's no difference. And when we look at investigation 2, the same conclusion can also be made. The graph manipulations, order does not matter. But when you change the types of translations and reflections that you're doing, you do get a difference. So in investigation 3 and 4, it matters whether you do the vertical translation and then the stretch, or the stretch and the vertical translation. So order matters. So order matters here, and we're going to have to come up with a convention that allows us to be consistent. And that is also true here, combining a horizontal translation and a horizontal stretch. Order matters. Um, check out the manipulation of the graph, practice that. And then we've got one example to do, and then a few questions in homework. So take a look at the generalizations. Order does not matter if I combine two translations, if two stretches are combined, if a translation and a stretch are at right angles to one another, if reflections and stretches are combined. Order does matter when a translation and a stretch are in the same direction or combined, and when most reflections and translations are combined. So unless you're told otherwise, we're going to use the following convention, and that is do stretch first, then reflections, and then translations. It's referred to as the SRT method. SRT, get used to that. The alphabet and SRT don't go well together, but deal with it. I'm going to just take a look at two examples from here and then get right to work. So we're remembering that we want to do the SRT method. Is a stretch done on this graph? Is there a horizontal change or a vertical change? Doesn't appear to be so. I do recognize that in going from A to B, there's been a reflection, and that reflection is in the y-axis. Reflection in the y-axis. And when I reflect in the y-axis, remember what changes. When I reflect in the y-axis, x becomes minus x. So if you flip that graph around, the graph would simply be in the mirror on the other side. But you'll see that I've done some shifting of that vertex. The vertex has altered position. And you can track what's happening to that vertex by looking at the graph. The vertex of the graph has moved 3 units up. So that's 3 units up and 2 units to the left. So 3 units up is a manipulation in y, and 2 units to the left is a manipulation in x. So this is one way of recording it. 3 units up, read directly off of the right-hand side of the equation. X has been replaced with minus x, and 2 units to the left gets an opposite sign, so plus 2. We're going to take a look at class example 2, trying to flip graph B to graph C. Let's take a look. So there's more than one way of making graph B get to graph C. I'm taking a look at these particular points. Those particular points are at minus 5 and 0, 0 comma minus 5 and 0 comma minus 10. And I like to see that I can rotate it or reflect it in the line y equals x. Kind of like doing that. Now remember, there are more than one way of answering this question. This is one way. The answer book might not be correct. My answer book has a slight modification. So when I reflect in the line y equals x, the corners that I've identified go to minus 5 comma 0 and minus 10 comma 0. So that will rotate my graph. So I'm just checking out the other vertices of triangle B or rectangle B. I took the other corners, minus 8 comma minus 5 and minus 8 comma minus 10. Flipping those around gives me minus 10 comma minus 8 and minus 5 comma minus 8. So I'll plot roughly where those points are. The graph scale is a little short. Maybe you caught this already, but I misread how low the graph goes. So I've got to alter that a little bit. So my graphing points, my first point was right, 0 comma minus 5. 0 comma minus 5 was right. But then I'm actually at 0 comma minus 6, 7, 8, 9. Misread that one. And then the other one is at minus 8 comma minus 9. So when I flip those points, I get minus 9 comma 0. I get minus 5 comma minus 8. And I get minus 9 comma minus 8. So I'm going to plot those in green and then see what we have to do to flip it. I was recording as I was drawing. There's my graph. And now I have to slide it up. I have to slide it up 8 units. So my first thing that I did was reflect in the line y equals x. Now I'm going to slide it up 8 units. So y has to have 8 added to it. And the x has to get replaced with, now it's a shift to the right, which means my x has to change to x minus 1. And that's going to shift the graph into the position indicated. So check out the pink sheet for the assignment, and thank you very much.